Hello guys, this is TJ. So let's discuss about divisibility rules now. So why is it so important? Guys, believe me, this will help you in your 10th standard syllabus, not only in your 10th standard syllabus, also in your 11th, 12th, also in the competitive exams such as SSCs, railways, even in UPSCs. These divisibility rules will help you in calculating the problems much more faster ways. So it will definitely save you some time. So it will be useful in like simplifications, in like approximations, as well as in finding the factors in that prime factorizations, then finding the LCMs. So in these areas, this divisibility rule is going to help you in a large manner. Okay, so you might wonder that why we have to learn the divisibility rules from 1 to 20. It is a very big list, 20 numbers, 20 different divisibility rules. No, it's not like that, guys, because most of the divisibility rules are actually similar. So you don't need to by heart many of the rules. Okay, we just have to understand, okay, this is the case, this is the case, this is the case. So within just seeing the number, even how big the number is, no issues. Even just by seeing the number, we can say that this is divisible by that, this is divisible by that. We can say that. We will be able to say like that after this session. Okay, so be with me. We are getting on to our first number, 1. Okay, we have a list of 20 numbers here. Okay, starting with 1. As you all know, every number is divisible by 1, guys. Every number is divisible by 1, or in other words, we can say that 1 is the factor of every number. 1 is the factor of every number. Clear? So that goes for 1. Let's give a tick mark for 1. 1 is done. Okay, every number is divisible by 1. Done. Let's hop on to 2. Okay, 2. Great. 2. Very easy. Very easy. Say all even numbers. Say all the even numbers starting from 2, 4, 6, 8 and any number 2, 4, 6, 8, 0. If any number is ending with 2, 4, 6, 8, 0, then those all numbers are even numbers, considered as even numbers, and those all numbers are divisible by, you said it, 2. Let's give an example. So let's write it just as a shortcut, all even numbers. Let's all even numbers. Okay, all even numbers. Let's take an example. Let's take a very big number. Let's say start with 7, 9, 8, 5, 4, 6, 2, 6, 1, 7, 8, 5, 3, 9, 2, 6. The number ended with an even number, so it makes the whole number, the given whole particular number as even. Therefore, we can say that this particular number which is on the screen is divisible by 2, or in other words, this particular number is a multiple of 2, guys. Yes, that's it. Done. Finished. Okay, so 2 is done. So let's give a tick mark for 2 as well. Done. Now let's discuss about 3. Yeah, 3. Okay, while discussing 3, I would like to discuss about the divisibility rule of 9 as well, because both are very similar. So let's discuss 3 as well as 9 together. Okay, I have taken a new page now. Okay, 3. So divisibility of rule of 3 goes like, you just have to add all the digits, dears. You just have to take the sum of all the digits. So if the sum of the digits is a multiple of 3, then that particular given number is divisible by 3. So let's take an example. Let's write a shortcut here. Just add the digits. You will get the signal by just reading this. Add the digits. Okay, let's take an example here. Let's take an example of let's take 312. Obviously it's divisible by 3, we all know that. Let's take, what we have to do here is 3 plus 1 plus 2, dears, and 3 plus 1 plus 2 is 9, obviously, right? No, not sorry, 6 it is, correct? So it is 6, and we know that 6 is a multiple of 3. 6 is a multiple of 3, so that brings us 312 is divisible by 3. Okay, so what we should say that here, it is multiple of 3. It is multiple of 3, which makes this number 312 is divisible by 3. Okay, 312 is also a multiple of 3. Okay, by the way. Okay, so definitely that makes that 312 is also divisible by 3. I hope it is very clear. And let's talk about 9 now without wasting any time. 9 goes to 9, the divisibility rule of 9. Okay, here also you just have to add the digits. Add the digits. That's why it's very similar. Look at here. Add the digits. Let's try the shortcut. Add the digits. Add the digits. So let's take an example and let's see. Example. Give me a number, guys. Let's take 288. 288 will do for you. Yes, 288. Let's add the digits. 2 plus 8 plus 8. And what is this? 18. And tell me, guys, is 18 a multiple of 9? Yes, 18 is a multiple of 9. 2 times 9 is 18. So it is multiple of 9. That gives us the given particular number is divisible by 9 as well. So the number here which is given is divisible by 9. Why? Because the sum of the digits of the number constitutes to a multiple of 9. So therefore we can say that the given particular number is a multiple of 9 as well as it's divisible by 9. I hope it is very clear. Moving to the next set of numbers quickly, we have actually finished 3 as well here. We finished 3, finished 3, finished 9, right? Moving to let's say 4. So here, dears, I would like to discuss 4 along with 8 along with 16 because they are similar, so it will be easy to learn. So let's go with let's say 4. Let's start with 4. Okay, so here you just have to concentrate on the last 2 digits of the given number. So obviously that if any two digit number is given to you and you have to check whether it is divisible by 4 or not, there is no other way. You have to divide it and see. Okay, so if a number is given which is more than 2 digits, you just have to concentrate on the last 2 digits. Okay, so if the last 2 digits, that is an unit digit and tens digit, if that number is a multiple of 4, then the whole number will be multiple of 4 and therefore it will be divisible by 4 as well. Let's see. So we'll try the shortcut as last 2 digits. By reading this shortcut, every divisibility rule should come to your mind. Okay, now let's give an example now. Let's tell me a big number here. No issues. Let's say 19344. Just to check the last 2 digits. 44, guys. 44 is a multiple of 4. We know 4 times 11 is 44. That means we can write that here. 44 is multiple of 4. Therefore that makes this particular number is divisible by 4 as well. Clear? And not that, if the last 2 digits are 0, if the last 2 digits is 0, then also it is divisible by 4. It will be divisible by 4. If you want to check, let's check the other example. Let's take one more example. Let's take the 100. Last 2 digits is 0. It is divisible by 4 because the last 2 digits is 0 and also it is a multiple it is divisible by 4 as well. No issues. Okay, now moving to the next so 4 we have actually completed, right? Let's give a tick mark of 4. So now let's discuss about 8. And what if I tell you 8 and 16 are only the divisibility rules which will actually trouble you? What if I tell you, will you believe? There are many other numbers which are still left, guys. There are 17. I don't like 17. 18. Okay, no issues. Looks good. 18 is a good fellow. Okay. Now 19. So you are telling that okay, 16 is giving more trouble than 17 and 19. Yes. What if I tell you yes. 16 and 8. these two divisibility rules will actually take a little more time than the rest of the divisibility rules. So let's get on to that. No issues. We will just deal with that. No issues. Come on. So let me take a new page for that. 8. Okay, 8. So we for the divisibility rule of 4, what we took last 2 digits, right? Last 2 digits. But here for 8, you should take last 3 digits, guys. Oh man, last 3 digits should be a multiple of 8 or it should be a 0. Some students might think that, sir, 8 is obviously 4 times 2. So why can't we check the divisibility rule of 4 and divisibility of 2, and if both satisfies, it also satisfies the divisibility rule of 8? No, it doesn't work like that, my dears. Then why do we want to check the divisibility rule of 4? 4 is nothing but 2 square. So why do we need a divisibility rule of 4, guys? Oh, okay, I will just I'll just clear your query, dears. Come on, I'll tell you. You know that let's say 116, okay, 116, it's obviously even number, so definitely the divisibility of 2 satisfies. The last 2 number is 16, so it definitely satisfies the divisibility rule of 4. So now let's check whether it is divisible by 88 or not. 116, 8, 1 time goes here, 3, 36. No. 4 times 32, the remainder is 4. So if we have a remainder, that means 8 does not completely divide 116. So like that won't work here, guys. We should have another divisibility rule for 8, and that comes like this. We should take the last 3 digits, and if it is a multiple of 8 or if it is 0, then we can say the given particular number is divisible by 8 or a multiple of 8. Okay, so let's take some example for that. Example, I'll give you 2 example. 8, right? 8. Let's take some example. 64. It's very easy now. We don't have 3 digits here. Oh, 64. Okay, let's take some other number. Let's take some big number. Like we already know that 816 is a multiple of 8, right? Now we'll just add some numbers to here. Let's take some 2, 3, 5. So if some number is given like this, what you have to do, you just have to take the last 3 numbers over here and check whether it is a multiple of 8. Okay, check whether the multiple of, this is a multiple of 8. Here we already know 816 is a multiple of 8, so I'm not going to check that by dividing. 816 is multiple of 8, multiple of 8. That brings us that this number is divisible by 8 as well. Similarly, if you see one more example, 235000, last 3 numbers are 0, therefore this is also what? Divisible by 0. Sorry, divisible by 8. Divisible by 8. Okay, I hope it is very clear. Moving on to the next, that is our main, that is 16. So we started with 4, which where we took the last 2 digits. Then we moved on to 8, where we took last 3 digits. Moving on to 16, you might have already guessed it. 16, take last 4 digits, guys. No, I don't have any other rules to show you. Take last 3 digits, last 4 digits. In fact, last 4 digits you have to check here. So if a number is given which is a 3-digit number, you don't have any other way, you have to divide it and check. If a number is given that is 4-digit, you don't have any method, you just have to divide it and check and whether it is a multiple or divisible by 16 or not. And if a 5-digit number or 6-digit number, 7-digit number is given, you can just take the last 4 digits and check whether it is divisible by 16, or if the last 4 digits is 0, then definitely the given particular number is divisible by 16 or it's a multiple of 16. Okay, so let's take an example here. So I'm just taking an example. Let's say 17776. Okay, 1776. Obviously this is definitely a multiple of 16, guys. You can just divide it and see. There won't be any remainder. It's a multiple of 16. Multiple of 16. Therefore the whole this given number is divisible by 16 as well. And if suppose if the last four numbers is 0, for example, let's take 10,000, the last four number is 0, so it is divisible by 16. Let's take 1 lakh, it's also divisible by 16 because last four number is 0. Okay, so I already told you 4, 8 and 16 is going to bother you a little. Okay, all other numbers is a piece of cake. So I think we can move to the next set of numbers. I think we have completed this. I'm not going to stay more on this particular numbers because definitely it will actually give a load on your head. Please release that load. No issues. Be cool, be chill. Okay, move to the next. So how much and all we have completed here, dears? We have completed 8 as well as we have completed 16. Now we move to 5, guys. So while discussing about 5, let's discuss about 10 as well. Let's discuss about 10 because both are very similar. Okay, both are very similar. So first let's discuss about 5. So the shortcut that you have to keep in mind is any number ending with 5 or 0. That's it. Any number ending with 5 or 0, all number ending with 5 or 0 is definitely divisible by 5. Okay, and moving on to 10. Any number ending with 5 or 0? No, just a 0. Okay, just a 0. I think I don't want to give any examples for this. I hope it is very clear. Moving on to the next set of numbers. What are the next set of numbers, guys? Come on. Let's give a tick mark to 5 as well as the 10. Next set of number is 6. So along with 6, I will discuss many. I will discuss while discussing 6, I will discuss 12 as well. I will discuss 14 as well. I will discuss 15 as well. I will discuss 18 as well. Okay, 6, 12, 14, 15, 18. I will discuss everything. It's very easy. Come on. Here, I will discuss here itself. 6, right? 6. So you have to check the divisibility of 2 as well as 3. That means the number should be even always. An even number, the shortcut is an even number and divisible by 3. What was the divisibility rule of 3? We should add all the digits, and if the sum is coming as a multiple of 3, then the whole number is divisible by 3. So similarly, you have to check whether it is divisible by 3 here as well, and if it is an even number, then only we can say it is divisible by 6. Okay, I hope it is very clear. Move to the next. I think we were to discuss 12, right? Yes, 12. So 12 is also very similar, very similar. You have to check divisibility of, you might have already guessed it, divisibility of 4 and 3. 4 and 3, guys. 4 and 3. Here it was 3 and even number. Here it was 4 and 3. So what was the divisibility of 4? Just check last 2 digits, and if it is a multiple of 4, then it is 3. Add all the digits. That's it. And next, moving on to 14. 6, 12, 14 it is now. Here you have to check the divisibility rule of 7 and 2. So it should be an even number, and divisible by 7. I already know that we haven't learned the divisibility rule of 7, but we will learn next. Okay, don't worry. So here we have to check the divisibility rule of 7 as well as it should be an even number. So if a number is divisible by 14, consider it is an even number. Then only it will be divisible by 14. But all even numbers are not divisible by 14. Okay, fine. Moving next, let's discuss about 16. 16 we already discussed, right? Let's discuss about 18. Or let's discuss about 15. 15. Very similar. So here we have to check the divisibility of. Ignore my spelling. Divisibility of 5 and 3. 5 and 3. So that means the number should end with 0 or 5, and it should also satisfy the divisibility rule of 3. Okay, so that is very important. Divisibility rule of 3, divisibility rule of 5. So if a number is ending in 0 and 5 and it also satisfies the divisibility rule of 3, then consider it is divisible by 15. Okay, done. Now let's discuss 18, right? 18. Okay, 18. Here, as you have already guessed, it should be an even number, an even number, an even number, and divisible by, come on guys, I can hear your voice, come on, divisible by 9. Because we already know why I am writing like this, because we already know 6 is 2 times 3. Here we already know 14 is 2 times 7. Here we already know 18 is equal to 2 times 9. That's why these rules are actually merging up. Okay, so I think it's very clear, very clear about the numbers. So actually let's tick out these numbers: 6, 12, 14, 15, 18. 6, 12, 14, 15, 18. 6, 12, 14, 15, 18. 6, 12, 14, 15, 18. 6, 12, 14 because 6 done, 12 done, 14 done, 15 done, 18 done. So what is remaining here? What is remaining here? Okay, let's discuss, guys, listen here. Let's discuss 7, 13, 17, 19 together. They are very similar, very easy. Please be with me. Don't skip this point. Don't like fast forward this point. Please slow it up. 17, 13, 17, 19. 7, 13, 17, 19. 7, 13, 17, 19. Okay, done. Let's do it. 7. So let's start with 7. 7. Here, the clue is, the shortcut clue is double the last digit. Double the last digit. And subtract the rest. And subtract with the rest. Let's give an example now. Only the shortcut I am writing here, okay? If the shortcut, with reading the shortcut, you should, every divisibility rule should come here, detailedly should come to your mind. So the example will go like, tell some example, multiple of 7, like let's say 217, okay, 224. Take out the last number, multiply it with 2, and what it is, 8, correct, and subtract with the rest. 22 minus 8 is nothing but 14, and we all know that 14 is a multiple of 7. Therefore we can say 224 is, don't confuse with the only 4, we are actually doubling it, okay, only the last digit, the unit digit, okay. Then 224 is divisible by 7. I hope it is crystal clear. Moving to the next. 7, after 7, let's discuss 13, or let's discuss 19, because 19 is somewhat similar to 7. 19, okay, move to 19. So the shortcut is, again, double the last digit. Double the last digit. But instead of subtracting, you should add here. So in 7, what you did, you doubled the last digit and subtracted with the rest. But here, what you have to do is, you just double the last digit and add with the rest and check whether the resulting is a multiple of 19 or not. Okay, let's check. Okay, just and subtract over here. This is clue only, okay, this is just shortcut, not the extended detailed manner of the divisibility rule, just the shortcut. By reading this, you should come, every detail should come to your mind. Okay, the example goes like, let's say an example of 19, let's say okay, let's say 1729, or just 729. I'm not sure with 1729. 729. Take out the last digit and multiply it with take out the last digit and multiply it with 2. just double it. So we will be getting it as 8 obviously, and add with the rest 72 plus 8, it is 80, right? Not sorry, 9 into 2 is not 8, it is 18. So 72 plus 18 is 90, right? Okay, 19. Okay, not 19, sorry, it's 90, right? 72 plus 18 is 90, and obviously 90 is not a multiple of 19, because 19 5s are I hope it is 95, not 90. So definitely we can say 729 is not divisible by 19. Therefore we can say 90 not multiple of 19. Therefore 729 is not divisible by 19. Okay, so I think we have to take one more example. Let's take one more example. Let's take 1729. 172 plus 18 will give you correct, yes, that is correct. We should have taken 1729. That came to my mind first. 1729. So similarly, let's take the last number, and let's what we have to do, just multiply this with the 2. So we will getting 18 here, add with the rest 172 plus 18 will give you 190, and we all know 190 is a multiple of 90, because 19 into 10, guys. So we can say that it is multiple of 19. Therefore 1729 is divisible by 19 as well. I hope it is very clear, right? Crystal clear, right? I think we can move to the next. Next is nothing but 13 and 17, right? So that's also very similar, not that similar, but we'll connect it, don't worry. So we are discussing about 13 now, right? 13. Here also the shortcut is about the last digit only, but not doubling 4 times the last digit, and add with the rest. So let's check with an example here. Let's check with an example. Let me give an example here. 729 will work over here, I guess. 729. Let's multiply 4 with the last unit digit, that is 9 here. So 9 into 4 will give you 36. 36 plus 72 is nothing but what it is, 8, and 108. Is 108 a multiple of 13? I don't know, I'm not sure. Okay, I'm not sure, so we have to check again. 108, so let's double 8. So let's double 8 and check. So let's double 8 and check. So we'll be getting it as I think we can do 1729 here as well. I think 1729 will work here. So 172, so that will give us not 10, 208. It will give it 208. Okay, so I don't know if 208 is a multiple of 13. So let's check again. So we have 208 right now. 208 right now. So let's take the last number again, multiply with 4. So we are going to get it as 8 into 4 is nothing but 32. So let's add 32 with 20. So I'm getting 52. I don't know, I am not sure whether 52 is a multiple of 13. So I'm going to do it again. 52. So the last number, let's multiply 2 into 4, that is 8. Then 8 plus 5 will give you 13. And 13 I know, okay, 13 is a multiple of 13. So we can say that 1729 is a multiple of 13, or it's divisible by 13. So that's the trick, guys, that's the trick. So we can say since 13 is a multiple of 13, 1729 and everything that we have written, 1729, 208, 52 is a is divisible by 13. Okay, I hope it is very clear. So what you have to do, you have to check the last digit and just multiply this 4 and add with the rest of numbers. And even if after that you are not sure, means again repeat the process, repeat the process until you are sure. Okay, so I hope it is very clear. Moving to the next. 13 done. So moving to the next, we will discuss about 17. So here also the trick shortcut is the last digit only. So but we don't need to double it, or we don't need to multiply it with 4. Instead we have to multiply it with 5. 5 times the last digit, and no need to add but subtract. But you have to subtract, guys. Okay, I will give an example now. Example is like I know 85 for sure, but so I am taking 85 anyways. So take out the last number, multiply it 5, so into 5. So 5 times 5 is 25, and you have to subtract with the rest. So 25 minus 8 will give you obviously 17. So since 17 is multiple of 17, 85 is divisible by 17 as well. I hope it is very clear. Let me take one more example. Let's take one more number. Let's take randomly, let's take 272. Take out the last number, multiply it with 5. 2 into 5, 10. And we have to subtract from the rest. So 27 minus 10, okay, it is 17. So again 272 is divisible by 17. So done. It's very clear, I guess. So let's I'll recap at the last, don't worry. So we have actually completed many set of numbers. Actually only a few is remaining. We have completed 13, we have completed 7, we have completed 17, we have completed 19. Now going to 11. Very simple. Please stay with me, guys. Please stay with me. 11. So here the shortcut is add the alternate digits and subtract. Not subtract the rest, okay? You have to add all the alternate digits. So the shortcut will just give, I will just give the shortcut as add alternate digits. Okay, so I'll give you an example here. So let's move on to an example. Let's say 2728. Randomly I have taken, I think it will work. 2 plus 2 you have to add, and 7 plus 8 also you have to add. So what 2 plus 2 is 4, and 7 plus 2, what is 7 plus 2, guys? So 7 plus 8, it is 15. So 15 minus 4, what is it? Is 11. So 11 is a multiple of 11. So this will work here. And even if the subtract, the answer comes as 0, then also it is a multiple of 11. Okay, let's check here. Not 2, let's check 3, 5, 4, 2. 3, 5, 4, 2. 3 plus 4, it is 7. 5 plus 2, it's also 7. So here 7 minus 7 is equal to 0. So definitely 3, 5, 4, 2 will also be a multiple of 11, or it will be divisible by 11. So let's check 3, 5, 4, 2. Divisible by 11, 3 times 33. So remaining 2, 4, 2, that is 22. Remaining 2, 2, that is 2 times 22, 0. So that is 322 times. So what I told, if the answer comes as 0, or if the answer comes as subtracted answer comes as a multiple of 11, then we can say that particular given number is a multiple of 11 or divisible by 11. Clear? Moving to the last, that is 20. Here the clue is last 2 digits. Don't worry, I will give you a detailed explanation of this divisibility rule at the last. Don't worry. Last 2 digits. The clue is last 2 digits. So what should come to mind is if the last 2 digits is 0 or a multiple of 20. For example, let's take an example now. Let's take 1, 2, 3, 4, 5, 6, 0. So I can see 6, 0. Just concentrate on the last 2 digits. Is it a multiple of 20? Yes, 20 times 3 is 60. So we can say it is a multiple of this whole number is divisible by 20, as 60 is multiple of 20. Clear? Now what if we say 1, 2, 3, 4, 5, 0, 0? Last two numbers are 0. So this whole number is divisible by 20 as it ends with two zeros. Clear? So you can say 100 is divisible by 20, 1000 is divisible by 20, 10,000 is divisible by 20, 200 is divisible by 20, 300 is divisible by 20, 500 is divisible by 20, 600 is divisible by 20, 6,500 is divisible by 20. So any number which is ending with two zeros is divisible by 20, or if the last two digits is a multiple of 20 means it's also divisible by 20. I think we have actually completed every number. 11 we completed, 20 also be completed. So that's it, dears. It's very easy. It's as simple as this. So let's quickly summarize everything. So I have here, so quickly within a jhatka, let's do this. 2, all even numbers are divisible. 3, sum of the digits should be a multiple of 3, then it is divisible by 3. Last two digits should be multiple of 4, then it is divisible by 4. Then 5, last digit should be 5 or 0. Very good. 6, an even number and divisible by 3. It should be an even number and divisible by 3. 7, double the last digit and subtract with the rest of the numbers, and if the answer comes as a multiple of 7 or 0, then the number is divisible by 7. Then 8, last 3 digit number is a multiple of 8 or last 3 zeros. 9, sum of digits should be multiple of 9. Then 11, add alternate digits and subtract together. Okay. 12, divisible by 4 and 3, divisibility rule of 4 and 3. 13, 4 times the last digit and add with the rest of the numbers, and if the answer comes as a multiple of 13, then we can say the number is divisible by 13. 14, it should be divisible by 7 and 2. 15, it should be divisible by 5 and 3. 16, the last 4 digits should be a multiple of 16 or 4 zeros. And 17 means last digit multiplied 5 and subtract with the rest of the numbers, and the answer should be a multiple of 17. And if it is 0 also, it is divisible by 17. 18, it should be divisible by 9 and 2. And we can say 19, just double the last digit and add with the rest of the numbers, and if the answer is coming as a multiple of 19, then we can say that particular given number is divisible by 19. 20, last two digit number should be 0 or last two digits should be a multiple of 20, then we can say that particular given number is a multiple of 20 or divisible by 20. That's it, my dear students. I hope this was very useful session. I understand that this might be a little bit confusing or difficult for some. Please practice for 1 or 2 hours after this session. If you are doing many problems, then it will be registered in your mind. So please invest 1 or 2 hours for this divisibility rules to get into your mind. Please, if you want to rewatch this video, please rewatch it because there will be some confusions in between for 13, 17, 19, for 16, 18, 4, and there will be some confusion. So please rewatch if you want, and please invest 1 or 2 hours for this. Okay, then these kind of divisibility rules will be registered in your mind, and it will never go from your mind. And it will be very helpful in your upcoming or 10th standard, 11th standard, 12th standard, or even in competitive exams like UPSC, railways, SSCs, everywhere. So I hope it is a very good session. So if you like this video and if you want videos like this, please comment in the comment section, and please subscribe to us and please support us. So this is me, TJ, signing off from Race. Bye bye. Take care.